Let's look at probably the most complicated way this question can be asked, where you have a combination of exponentials and trig functions, real valued exponentials, so something like e to the 2x, and then some kind of trig function, 3x, I guess. So you can do this by integration by parts, and it'll be a fairly long problem, but it's doable. But if you had to do it with complex exponentials, which is probably the way you shouldn't do it, it's going to be a bit longer. But let's see how this goes. The initial step is the same. Change this trig function to using Euler's formulas. So this becomes the integral of e to the 2x. Cosine of 3x becomes e to the ix plus e to the negative ix divided by 2. So we're going to distribute, same thing. The only problem is that this exponent here does not have imaginary numbers inside it. So it's going to make it a bit complicated, or we'll pull a 1/2 out to start. This becomes e to the 2x. We're going to write it all the steps just to be safe, plus ix. So e to the 2x plus ix for this one. Then when we distribute again, we'll get plus e to the 2x minus ix. Just adding exponents, dx. We'll clean this up a bit. Notice in the exponent you have a common factor, x. So we'll pull it out and get 2 plus I times x plus e to the 2 minus I times x. So we factored out x in both exponents. Now this is, at this point, it's very easy integral. This is a weird looking constant, but this is still just a constant. So when we integrate, same shortcut, exponential, the antiderivative is itself, 2 plus I x, and you're going to divide by 2 plus I, because that's a constant. And same thing here, 2 minus I x divided by 2 minus I. Okay, so this little step kind of ruins it, because we don't have just a single number on the bottom, we have two numbers. So it's very difficult to go back to trig functions at this point. Remember that it is unfortunately not the case that e to the 2 plus I x over 2 plus I, this is unfortunately not equal to e to the 2 plus I x over 2 plus e to the 2 plus I x over I. Fractions don't work like that. It'd be nice if they did, but they don't. So that's alright, we'll try something else. Let me write this out because we're going to need some room here. Okay, so remember how we divide complex numbers from the supplement? You divide it by a complex number, you just multiply by the conjugate of the bottom. So the conjugate on the bottom here is 2 minus I. Multiply on the bottom by that, you've got to multiply on the top by that. And then we'll do the same thing on the second exponential term. So multiply by the conjugate. In this case, the conjugate is 2 plus I. Just another side note. Actually, so when you find the conjugate of a complex number, you have to make sure it's in the form, the correct form. A plus bi. The conjugate would be a minus bi. So if you see a problem where they ask you something like, what is the conjugate of I minus 2? The conjugate would not be I plus 2, because this is not in the correct form. What you would have to do instead is change it to negative 2 plus I, and then it's more easy to see that the conjugate would be negative 2 minus I. So just keep that in mind. So anyway, getting back to our problem, we're going to multiply out the bottoms here very carefully, and that's going to require some foiling, so this becomes 4, multiply first by first, you get 4 minus 2i plus 2i minus I squared. Obviously these cancel and you get 4 minus I squared. 4 minus I squared is negative 1, so this is 4 minus negative 1, which is 5. If you see what's happening here, this is the same exact problem on this side. So this also becomes 5. Okay, so we're going to rewrite that. Again, you don't have to write out every single step that I'm doing. I'm just doing it to be safe. I made a little bit of a mistake here. This should be right here. This should be 2 plus I on top. Again, apologies, it's now 12:52 a.m., so I'm trying to catch my mistakes as they come along. Okay, so this is my problem so far. Now I'm going to pull this 5 out because it's in both. So I'm going to factor that out. I'm going to get 1 over 10 on the outside. Just to get rid of fractions because I hate fractions. Now on the top, I'm going to distribute this exponential term to the 2 and to the negative I. So I will get 2e to the 2 plus I x. I need some more room here. Minus I e to the 2 plus I x plus 2e to the 2 minus I x plus I e to the 2 minus I x. Okay, getting a little better, making progress. So at this point, I'm going to redistribute these x's back in. And so I'll get 2e to the 2x plus ix minus I e to the 2x plus ix plus 2e to the 2x minus ix plus I e to the 2x minus ix. Okay, so recalling one of your properties of exponents, e to the a times e to the b equals e to the a plus b. These problems will simplify instead to 1/10 2 e to the 2x e to the ix minus I e to the 2x e to the ix plus 2 e to the 2x e to the negative ix plus I e to the 2x e to the negative ix. So every single term has an e to the 2x in it, so we're going to factor that out. We'll get e to the 2x over 10 times, and what are we left with? 2 e to the ix. Again, we're being really thorough here, but it doesn't have to take this long. Minus I e to the ix plus, so we got rid of this. No, we got rid of this. Plus 2 e to the negative ix plus I e to the negative ix. Okay, looks good. Now we're going to group together this time we're going to group together terms that have similar coefficients. So they all have the same exponent in this problem, so we'll group them by similar coefficients. So I'm going to put this one with the other exponential having a 2 in front, and then the ones with i's together as well. Now I still want the positive exponent to come first. So I'm going to factor out a 2 from these two, and I'll have e to the ix plus e to the negative ix. Factor out an I from these two. E to the ix plus e to the negative ix. See, we may have lost a negative here. Should be a negative right here. I'll clean that up a bit. Yeah, so we lost this negative here. So we'll put that back. And we'll factor out an I. Let's do this. Let's factor out a negative I. So negative I. And then what are we left with? E to the ix. If we factor out a negative I from this term, we're left with minus e to the negative ix. So again, you look at the sign here in between. This tells you where you're going. If it's a plus, you're going to try to get back to cosine. If it's a minus, you're going to try to get back to sine. So drop down e to the 2x over 10. Okay, so to get back to cosine, we need to have a 2 on bottom, so we're going to multiply it by 2 over 2. And here, to get back to sine, we have to have a 2i on the bottom, so multiply by 2i 2i over 2i. We'll highlight what becomes what. So this whole thing will become cosine, and this whole thing will become sine. So what are we left with? 4 cosine of x. Here we're left with minus 2i squared. So minus 2i squared plus 2 sine of x. Okay. You could simplify this just a bit. E to the 2x over 5. And this becomes 2 cosine x plus sine x plus c.